Hey y'all, I want to show you how to solve quadratic equations. So essentially, okay, so what we're going to do is we're going to have an outline and it's going to look like this. We're going to have the square plus bx. We're going to have a constant. We're going to have that equals 0. This one's important right here. It has to equal 0, right? So the a, b, and c, those are going to be numbers, right? We're going to have some kind of numbers, and those are called, well, the first two are called coefficients. If it's naked by itself, it's called a constant. Let's type that up. Coefficient. You think I'd learn how to spell this word by now? I feel like that's wrong spelling, but that's what we're doing today. This third guy, this letter C, if it's naked by itself, meaning there's no alphabets touching it, it's called a constant. Constant, right? So the first two are coefficients. That one's a constant. The x's right here, those are called variables. Variables. Right? So if it's A or B, it's a coefficient. If it's C, it's constant. And if it is X, it's a variable. And if there's a plus or minus sign, which this could technically look like that, it's a, what is it called? An operator. Operator. It's not that important, but I might accidentally start using these words when I'm describing things, like in the examples. It might be useful to know it in this particular context. In general, yeah, it's really important, super important, because no matter what math class you take, these words are going to come up. Well, maybe not operator, but the other three certainly will. So all we're doing is we're taking this guy that I just wrote, and we're going to factor it. So it's going to look like this. You know how they have that plus or minus with a random number, and then there's x plus or minus with a random number? We're going to take that, and then, all right, you guys saw where I worked. Okay, so you're going to take that, and we're going to equal it to 0, right? We're going to equal it to 0, and then we're going to test it. We're going to put the answer that we get back into that. Okay, cool. So that's what we're doing. I'm going to show you with some examples. That way, I don't know. Did I explain it well? Maybe not. Who knows? We're going to do examples. That way we can get a better understanding of what's expected of us, I guess. Okay, cool. So step one is we got to do that outline we just saw, which was ax squared plus bx, right, with just a 1, plus c equals 0. That's the setup we have to do. So this is going to be a, this is going to be b. This is technically c because it's a constant. Remember, a constant is just a number hanging out by itself. There's nothing touching it. But the thing is, there's no 0, and 16 is on this side of the equal sign it's not supposed to be on. It's supposed to be hanging out with its buddies. It's way over there isolated. So what do? I'm going to move this over by changing the sign, and I'm going to make everything equal 0. So what does that look like? Let's get rid of that. Let's get rid of that. What does that look like? It's going to look like this. We're keeping the first two terms exactly how it is. I'm going to do negative 16, right? Because I moved it over and it became negative 16 equals 0, right? So all I did is just adjust some stuff, and this is the question now, because it was solve this, now it's solve this. Now we can actually do the setup. So I'm going to do the factoring thing, right? It's like reverse FOIL. So I got to figure out what is multiplied, two numbers that are multiplied to give me 16, and what new numbers do I basically add to give me negative 6. So we got to figure that out. Let's see, what can we use? So what would be 16? And then I have negative 16 and negative 6, right? So this is going to be add. The second one is going to be multiplied. This one's going to be add, subtract situation. Let's see. Well, we can do like a 2 and a negative 8, right? We could do that. That'll make a negative 6. And a 2 times negative 8 also makes a negative 16. So let's use that. Let's do 2, and then we have a negative 8. And if there is no negative sign, it's understood it's positive, so this becomes a plus, right? So we got the factoring down. So now we're going to make this factoring thing equal 0. We're going to have two of them, right? I have the first one and then the second one. Now I'm going to isolate the variable. The variables are the x's. That we're basically getting the numbers by itself, and we're going to make sure the alphabet is absolutely totally by itself alone. Nothing can be touching it either. So what does that give me? It gives me a -2. Because all I did is move the constant over to the right side. And the constant is a 2. And in this constant, it's a -8. So if I'm moving it over, it becomes +8, right? So this is technically my answers. But here's the thing, I have to check. I have to check my work. How do I check it? The answers I came up with, I just throw it right back into the original question it's asking. That's it. So with variables, which is those letter x's, that's a placeholder. It means what number goes in there to equal 16. I got to pick some random numbers that would go lock into place. And if I were to put that into a calculator, it's literally going to say equals 16. Why 16? Well, because that's what they gave us. That's why. That's how we know it's going to be 16. So let's try that out. So we have to do it twice. I have to test it twice because I have to do one for -2 and I have to do one for 8. So let's try it. Let's do one for -2. I'm just going to do the outline, and any place that's a variable, which is that x, I'm going to leave it blank because I'm just going to, I'm going to fill it in with my -2. Let's do a line down here, and then I'm going to fill it out again with these blanks. I'm going to put my 8 in there this time. -2, -2, and this one's an 8, and this one is also an 8. So let's see. When you have a negative, when you're multiplying a negative number with the square root of 2, it always becomes positive. So this is immediately 4. It's +4. Because what you're essentially asking is -2 times -2. Two negatives multiplied become positive. -6 times -2 is going to give me a positive. It's going to give me +12. And this is going to be 16 because it told me so. So 4 plus 12 is 16 equals 16. That's our goal. We want both numbers to be exactly identical. That's right. If the first one is right, so if like the first one, which is -2, that answer, if it's right, there's a very, very, very high probability the second one you're about to test is going to be right. There's an off chance it's not going to be right. We could have done the math different somewhere. But if you got half of it down, there's such a high opportunity for the second half to be right too. So what is 8 squared right here? Well, it gives me 64. And then 8 times -6 is going to give me -48 or -48. And we're going to do the 16. And 64 minus 48 is 16, which gives me another 16 on the right side of the equality symbol. So that's right. If they equal, it doesn't matter what they equal. They both have to be the exact same number, right? Not with each other. They could be different numbers, but we need this to be the same. We need this to be the same. Okay, cool. So what does that mean? It means this is right. The numbers we basically guessed up is correct. So our final answer, let me get rid of some of this here. Our final answer is x equals -2 and 8. That is our final answer. This whole thing we did down here, we're just testing it. So here's what's up. Like, if you feel real confident that you got the answer right, you just don't feel like testing it, just skip that step. You don't have to test it. You can just box this up and go, here's my final answer, and just submit that as your work, right? I mean, you could be wrong, but I mean, it's totally up to you. This testing thing is just something in the bottom to help you out. We're going to try more examples. They're going to be different layouts so you can see how to adjust it to give yourself the quadratic equation setup, right? So let's see. I have this one right here. It's set up again very differently, right? And that setup we were talking about is, I feel like I should have written this down like on every slide for y'all. plus c equals 0. Now, technically, it's either plus or minus, and that's what this looks like right here, the plus or minus symbol. I feel like that's really heavy, like there's a lot going on. It looks kind of like a very busy kind of formula. So I don't know if that distracts or like diminishes the confidence you're building. So let's try this one. So I have to make sure that I have everything on one side and it has to equal 0. So what do? We'll just push everything over to one side. So I'm going to get a positive 6y plus 5 equals 0. Here's the thing. You could do it the other way. You could just put this over here and you could have a negative y to the second, right? You could do that as well. There's a handful of different ways you could do this. I'm going to implement this method. That way we can keep it positive up front and it makes it a little bit easier for us. What do I do now? Second is factoring. Step 1 is cosmetics. I got to make it look like this, right? Step 2 is factoring. What do? Well, I have to make sure that I get something that is either added or subtracted to give me 6, and something that's multiplied to give me 5. What numbers could those be? Well, off the top of my head, and immediately 5 and 1, right? 1 times 5 is 5, and then 1 plus 5 is 6. I'll put the letter y's up front, and it's understood it's positive because there's nothing up here to affect it, right, to tell us otherwise. So it looks like I got the factoring stage down. What's next after that? So after the cosmetics that we did right here, and after factoring, I take my two little factor bits and I equal it to 0. Equals 0, and then I have y plus 5 equals 0. And then my goal is to make sure I get my variable totally alone by itself. So y equals -1, y equals -5. Now this could be my answer. I could just box it and move on, but we're going to check our work. And how do we check our work? We're just going to go ahead and put it in to the original formula it gave me, the original equation. And there's 2 of them, so we got to test it twice. Squared equals -6, mystery number, -5. Let's do the second guy. 2 equals -6 space -5. What am I putting in there? -1 into the first one. And I'm going to put -5 into the other one. Cool. So anytime you're multiplying a negative number with an nth degree of 2, you're going to make it positive. So that's going to be a 1 equals, this is positive 6 minus 5. So we bring the 1 down. 6 minus 5, that's a 1. Well, hey, man, that checks out. We're good to go. So this one is correct, right? Let's try the other one with -5. Okay, so -5, it's going to be positive 25, right? Because it's saying -5 times -5 times -5 times -5 times -5, right? So it's going to give me a positive number. Equals -6 times, what is it, -5? Yeah, it's going to give me a positive. I already know that from the jump. And it's going to be a 30 minus 5. Well, I bring that 25 down. 30 minus 5 is a 25. Sweet. Look, man, we got that right too. Do you see how they're different numbers? It's 1 equals 1. And then this one is 25 equals 25. It doesn't matter what the numbers are, as long as they equal each other. Like this is its own group or club, and this is its own group or club. But they're both right. So this is the final answer. This is the final answer. This is just us checking. You don't need to submit this. I mean, I guess, unless they ask you to submit it. But the final answer that you would turn in would be this guy and this guy. Let's do more. Okay, so this is an interesting problem, right? So, okay, so we have to set it up, as we mentioned, where it looks like this. Constant and 0, right? So basically we have 3 pieces and then we have that 0. But if you look here, there is not 3 pieces plus 0, there's only 2 pieces. And it's already set up with the format I need, which is the quadratic equation. This is the quadratic equation, right? Set up. So what's going on? How do I do this? Well, technically, it's going to look like this. Plus 0 minus 16 equals 0. right? Because like in here, the centerpiece is missing. B is missing. This is A, this is C. How do I know that? Well, because see that number 2 up here, right? So this is a quadratic. A quadratic is going to have a little 2 dangling at the top, and it looks like this, basically. Like if you were to graph it. It can look like upside down as well, or right or left, but it basically looks like that. A quadratic is like a bell curve. It's like a little bendy letter U. A linear is just going to be one line, right? So, I lost my train of thought. What was I talking about? I was going to say, oh yeah, I remember now. So we're missing B. So when you're missing one of them, the placeholder is assumed to be 0. And this is actually, it has a special word for it. It's called an incomplete quadratic. It basically has a missing term. But we know that it's technically not missing. We just put something in. We put in a 0. So sometimes these get tricky. And it feels like you're doing something wrong, but you're totally not. Just put that 0 in. You kind of have to know where the 0 goes because, look, man, you got to know it's a B. You have to know. You're not going to do 0 times x. You're not going to do that. It's just going to be straight up a 0. That's it. So let's go ahead and try solving this. So what are we solving? It's a factor method. What are we solving? Well, we're going to do the exact same thing we've been doing. I'm going to find something that basically 2 numbers equal 0 if I were to add or subtract. And I'm going to find a number that 2 numbers that basically multiply and give me negative 16. What could those be? What could those possibly be? Well, I can't do like a 0 times 16 because that's not going to help. But look, man, look. 4 times 4, it does give me 16. I can make one of them negative. That way I can get a negative 16. And if I did 4 plus minus 4, or 4 minus 4, those are 0. So now I know that I can use 4s. These are the ones that work, because if I multiply 4 and 4, it gives me 16. If I subtract 4 and 4, it gives me 0, right? So let's put our little placeholders of x. And let's see, I'm going to do a 4 here and a 4 here. One of them have to be negative. The other one is just positive as it is. So now what I do, I did the cosmetics, which was the little setup. Then I factored. Now I have to take that factor and make it into 0. And I'm going to get 2 of them because I have 2 little factor guys. I have 2 parentheticals right here. And then I just get x by itself. I have to make the variable become isolated. Isolating the variable by changing the sign. Isolating the variable by changing the sign. Great. Now this is what I assume is my answer. I feel pretty good it's my answer. Maybe it's not my answer. I'm going to test it. How do I test it? I throw it right back into the original problem it gave me. What I like to do is I like to just rewrite it, and I like to have my giant gap there so I could just fill it in with whatever I want or need. That's what I like to do. So I'm going to fill this up with -4, and I'm going to fill this up with 4. And as soon as you do these, you're going to know as soon as you write it down before even solving it, you know it's going to be even. How do I know it's going to be even? Because anytime you have a negative and you're placing it against the nth degree of 2, it's going to be positive. That's how we know. And it's the exact same setup. So we're going to end up with the same exact numbers. We're going to end up with 16 on both. And it's going to say -16 on both equals 0. So that's how we know. That's how we know that, but just by visual, if you kind of, I know it's a lot because you're still kind of learning this stuff, but if there's a way you can train your eye to kind of see ahead, it's useful. So this over here, we know it's going to be 16 because what it's asking is -4 times -4, right? And we already know it's going to give us a positive because 2 negatives make a positive. 16 minus 16 equals 0. This is 0 equals 0. It checks out. It's the exact same number. What about this? This gives me a positive 16, and I bring this down. It gives me -16. I bring this down. It gives me a 0. It gives me 0 equals 0. Checkmate. Those are great. Those are right. So these are my final answers. I have x equals -4 and a positive 4. Those are my final answers I would turn in. Let's try another one. I'm getting a little bit fatigued already. Okay, let's see, this is also a incomplete quadratic, but it's a little bit different than what we just did. This is what we have, right? This is a little invisible one. You don't necessarily have to draw, but it exists. So let's see, let's label it. We have A, we have B, C is missing this time. We don't have a constant this time. So what would that look like? We can do a placeholder. You don't have to, but I mean, I do one. I think it's useful. Why not? Right? So this is what we just added. And I just stretched and pulled it apart and I just threw in the C that I needed. That's all I did. So what does that mean? That means I need to find something that either adds or subtracts to 6, two numbers basically. And I have to make sure those exact same numbers I selected basically, when multiplied against each other, give us a 0. Now that's tough. You're like, what does that mean? Well, let's go ahead and set it up. We have our x's, right? And we're going to do either plus or minus, and we're going to have our number that we picked. So the secret to kind of doing something like this is remembering that any number you multiply against 0 is 0. So whatever number I pick, it's going to be 0 for multiplication. So let's put a 0 in. Why not? Whatever number I put here, it doesn't matter because my final answer is totally going to be 0 for multiplication. So what number when I'm adding gives me a 6? Well, we could do 6 plus 0. That gives us a 6. And look, 6 times 0. That actually gives me a 0, which is precisely what I need. I need a 0 and I need a 6. So let's do 6 and 0. And I know it's kind of weird putting in a 0 in our factoring because, you don't really come to that often. That doesn't happen very often. But sometimes you do. Sometimes you're going to get weird numbers. Like it kind of gets a little bit trippy, as we do more problems. So let's see. What's our next step after we factor? Well, I got to get these factors to equal 0. All I'm doing is just copying exactly what I see inside the parentheses and putting a 0 at the end. Then I'm taking the variable, which is x, and I'm isolating it by just flipping the sign. With 0, it's always going to be 0. There's no sign change. Okay, this is what I assume is the answer. I'm presuming that my final answer is 0 and -6. I could just box this up and move on to the next problem, or I could be one of those diligent students and check my answer. So let's be diligent today. I'm just going to have these little open gaps where I put my mystery numbers in. And what are my mystery numbers? -6 and -6 on the first go, and 0 and 0 on the second go. And our goal is to make sure that the numbers are equal on both sides of that equal symbol. But they're two different formulas. I mean, they're two different problems. So like, they don't have to exactly be matching. It just has to be cool on one group and cool on the other group. So let's see. -6 squared, what does that give me? So -6 squared, you have to remember that when you have a negative squared, it's going to be positive. So immediately we know it's going to be positive. The second you see a negative and a square, try to put that little positive symbol down. It gives you 36, by the way, right? So, because they're asking 6 times 6. And then we have 6 times -6. What does that give us? Well, we know it's going to be a negative right away. 6 times 6 is 36, equals 0. I brought that down. What is 36 minus 6? Well, it's 0, equals 0. It looks like that's right. It looks like we got that right. Let's try the other one. Okay, let's box this to indicate that this is correct. So now we got the first one right. There's a strong indicator that the second one's going to be correct. We're not always accurate with that, but let's try to see. What is 0 squared? Well, that gives me a 0. And then we mentioned earlier, what is 6 times 0? Anything multiplied against 0 is in fact 0. And we're going to bring down the 0 that it gave us on the right side of that equal sign. What does it give us? 0 equals 0. Cool, sweet. Looks like that is cool too. So these equal each other, and then this separate formula, it also happens to equal each other. Therefore, this is also correct. So these are my final answers, these two guys. Let's try another one. This is a really great one because it's all over the place. And remember, this is our formula that we're using. Plus c equals 0. So what do we do here? Because it's all over the place. There's like 6 different terms. What do I do? Like, this is kind of intimidating, but it's totally super easy. You know how to do this. Okay, all you're going to do is you're going to move everything over to one side. It doesn't matter which side, just pick a side. We've been putting everything to the left side, so let's keep doing that. All I'm going to do is I'm going to find the same term and I'm going to join it. So I'm going to do negative x to the second here, and I'm going to find where the second is. We're going to do negative x second here. This gives me a 0. This is going to give me a positive because 2 is bigger, and it's going to give me x to the second. That disappears. Let's do the 6x next. We're going to do negative 6x because my goal is to get rid of it. So 6 minus 6 is 0. And I find its like term and I move it here. So this is a 0. We got rid of that. And what is 2 minus 6? What does that give us? Well, we know it's going to be a it's going to be a negative. It's going to be negative because 6 is bigger. And we know it's going to be 4 because 6 minus 2 is 4. Or you could say 2 minus 6. And we keep that x. What about that 5? I'm going to do positive 5 to get rid of it. And I'm going to move it right here, positive 5. And what does that give us? Let's move it down here. It's because I'm running out of room. Well, we know it's going to be positive because that 5 is bigger, and it's going to be a 4. Cool. So this is basically the new question it's asking me. This was the question it was asking me, but I adjusted it. What did I adjust it to? X squared minus 4x plus 4 equals 0. That's the new question, and it matches up our formula. Now let's go ahead and factor this guy because it's way, way, way easier to factor this than all of this. Let's put our x's together, and I got to find something that, 2 numbers that multiply to 4 but also add up to be negative 4. What could those numbers possibly be? Well, we could do negative 2's. Those would work, right? Because negative 2 times negative 2 gives me a positive 4. And negative 2 minus 2 gives me a negative 4. Right? So that's how I know it's going to be negative 2. Let's see. What do I do next? Well, I'm going to make sure that I make it equal to 0. This one's an interesting problem in a lot of ways. So now I'm going to isolate. I'm going to isolate the variable. Great. I should probably make them look alike. Okay, great. If you look at these variables, they're the exact same answer. They're both positive 2. There's nothing wrong with that. You didn't do anything wrong. Sometimes it's going to be the exact same number. Sometimes you're going to get a fraction. Sometimes it's going to get weird. These are both the exact same number. That's totally chill. Not a big deal. So what does that mean? When you test out your answer with like the original, what you're going to end up doing is you're only going to have to test it once. You don't need to test it twice, because if you put in a 2 into like the variable, into like the placeholder number, which is x, you're going to get the same answer every time. So you don't got to redo it twice. So let's go ahead and try it out. So we're going to go into the original white font number. We're going to do these giant spaces. Wait, is that an equal sign? Yeah. So let's do an equal sign. Let me erase this. Okay. We're going to do this gap here, plus 6 gap. What is that, minus 5? Okay, perfect. And I think I'm going to put the 2 in here, right over here, and then up into this. All right, cool. So what does that give me? Well, we're gonna do 2 times square root of 2. Let's see, which gives me 2, and that gives me a 4, right? Plus 4 minus 1 equals 4, plus 12 minus 5. And then we're going to put these together, which gives me 8 plus 4 minus 1 equals 4 plus 12 minus 5. Great. So let's go ahead and use the subtraction. It's 8 plus 3 equals, let's do the 12 minus 5, which gives me 7. 4 plus 7. Great. So 8 plus 3 is 11. 7 plus 4 is also 11. Great. These are equal to each other. They're both equal to each other. That means the answer is, in fact, x equals 2. That's it. You just have to submit one single answer because both of them are the exact same thing, so both represent both of the factors that we were messing with. Well, that's exciting. Let's do another one. Here we have another one that could potentially look incomplete, but we're going to create our own 0. All we're doing is throwing this over to the other side. We're going to just throw a 0 in. What does that look like? 7x, and we're going to change the sign. We have to. When we throw things over to the other side of the equal sign, we got to change the sign up, right? So here is a complete quadratic. It has a, b, and c. It has ax squared, which is the x squared up front, and then it has bx, which is the 7x, and then it has c, which is our 10, and it has a 0 at the end, as indicated at the end. So what do I do after the cosmetics? Well, I factor. And I got to see what two magical numbers are going to multiply to 10 and what two magical numbers are going to basically add up to 7. Now, sometimes it takes a minute. You know, sometimes you can look at it and you can immediately know what numbers to use, right? So what numbers can we use? I mean, it's like, okay, let's go ahead and write it down. I have 7 as positive and I have a 10. It's positive. We have to remember that. We have to remember the signage. Because if you get the wrong sign and you're doing all this math, you can totally change the game and it's going to give you the wrong answer, which is a super bummer because, you know, our goal is to get the stuff right. So let's see. I think a 2 plus 5 equals 7, and then a 2 times 5 equals 10. So maybe we can use 2 and 5. They're both positive, so I don't have to mess with the signage. I can just keep it positive by default. If there's nothing indicated, it's just going to be positive by default. Right? So I did the cosmetics, I did the factoring, and now I got to make sure the factors equal to 0. And then I got to isolate my variable by switching up the sign. So these are my two final answers, -2 and -5. That's what I'm guessing it is. I feel like I did an educated guess by working on the math. I can move on. I can just box this up and move on. But I'm going to test it out just because, you know, that's the game here. And all I do is just get rid of the x's and I'm going to replace it with my numbers that I picked out. Right? And where did I get this equation? It's the white font. You just go back to the original and then you just throw it in there. It's not the one we made. It's straight up the original question that it's giving you. That's the one you throw it into every single time, right? So whatever's printed on your piece of paper or in your textbook, that's the one you throw it back into. What do we got? We got -2, and then we got a -5. Now we got to remember, when you're getting a negative against the square root thing, I mean the nth degree of 2, right? It's going to be a positive number. So we have 4, and then I have a negative with this 14 equals -10. Well, 4 minus 14, that's going to give me a negative number. We know that right away because 14 is bigger than 4, and that 14 has that negative number, right? It has that negative sign. That's how I know it's going to be negative. And it gives me a -10. If I bring down anything on the right side of that equal sign, it also is a -10. So this is correct, right? It equals out, so this we know is right. Let's try the other one. So -5 is going to be 25. And then I have this, it's going to be negative. Yeah, it's going to be negative, and it's going to be 35. Because, yeah, that's a -5, right? Yeah, we got -5. Equals -10. So it's 25 minus 35. I know it's going to be negative because 35 is bigger, and it's going to be 10, right? Because 25 minus 35. And it equals -10 because that's what we brought down. These are the exact same numbers. Therefore, this -5 is also correct. As long as it equals the same number to each other. Not the whole thing, but just to each other. Just to each other, it's chill. It's good to go. So it's -2 and -5. Sweet. We're going to do more. Let's see. I think there's a few more. Well, this one's all over the place, right? Okay, so it looks like we have A right here. It looks like this is B. And then it looks like this is C, our constant. So it looks like everything we need to do is just throw everything on this left-hand side, and then we got to equal it to 0. So it looks like we don't have to do a lot of work with the cosmetics. So what is it going to look like? It's going to look like y squared minus 18y. We're going to do positive 45, positive, right? It started negative, we're doing positive, and we're going to equal it to 0. The cosmetics are done, right? So this was the cosmetics game. B squared, b1 plus c equals 0. By the way, if you hate factoring, like you just can't stand it, and you hate that factoring stuff, you could do the you can do like the quadratic formula instead, right? It's just going to be very time consuming. It looks like this. B squared minus 4ac over 2a, right? And I have a video on this. It shows you how to memorize this in like less than 30 seconds. And you can use this formula instead, because here's the thing. This is the same thing, A, B, C. This is A, this is B, this is C. All you do is just throw those in there. You just throw those numbers in here. That's all you do, right? So you just solve it. If you have a calculator, and that makes it super quick, and you're going to end up with 2 answers. Why do you end up with 2 answers? Because you're going to throw the whole entire thing with the plus sign right here, and you're going to redo the whole thing with the negative sign. So you end up with a positive version and a negative version. And when I mean version, I mean the answer. It doesn't necessarily mean it's going to be positive or negative. So the factoring game and then this quadratic formula game, they're going to give you the same outcome. You're going to get the same numbers. So if you just don't feel like factoring and you just want to plug everything into a calculator, go ahead and do that, if you're allowed to. You know what I mean? So let's see. So I do have everything set up. We're not going to do the quadratic version. We're going to do the factoring version. So we're going to do the factoring version. So we're setting it back up again. So we have y here. Now I got to figure out what numbers, what 2 magical numbers are going to give me a -18 if I were to add it together, and what 2 magical numbers are going to basically give me a 45, a positive 45. This one will take a minute, right? Because these are bigger numbers. They're not like, you know, something that's around like 10 or something, a single digit number. It's going to be a 3 and a 15, by the way, right? 3, 15. But they're both, they're going to be negative. So let's go ahead and do that. For time's sake, because I feel like this video is getting really, really long if anyone is watching this. So what I'm going to do is I'm going to make this equal 0, and I'm going to make the second guy also equal 0, right? And then I'm going to isolate the variable, positive 3, y equals positive 15. Now, these could technically be my final answer, but what I'm going to do is I'm going to input it into the original formula in the white font, right? So we're going to do those gaps so we could place our answers in, equals -45. Oops, 45. I'm going to do that again a second round, -18 with my gap equals -45. Sweet. So I'm going to put a 3 in here, a 3 in here, a 15 in here, and a 15 in here. What does that give me? Well, 3 squared gives me 9. -18 times 3, that's going to be 54, equals -45, right? And then, let's see, that's 9. Oh, and I got to bring it over. 45 plus 45 equals 0. That's going to give me 0 equals 0. 45, 9. Yeah, it's 0 equals 0. And then I have this over here, which is going to be 225. Wait, I think. Let me look at my calculator. Hold on. 225. Yeah, sweet. And then 18 times 15 is Negative 270 equals negative 45. 225 minus 270. I'm putting all this into my calculator. Numbers are a little bit too big. 45 and 45. Sweet. Those match up. Looks like this guy is correct and his buddy is also correct. Hooray. Let's do another one. These are a lot. Let me see how many more we got, because we got like 4 more. All right, maybe we can soldier through these. I mean, you can click out, but I'm going to soldier through, perhaps by myself. Okay, let's see. Here is another incomplete equation, right? Quadratic, rather. Quadratic equation. Okay, so let's go ahead and label it. This is my A. This is C, because a C is just going to have a number naked by itself. Nothing is touching it. What's missing? The B, right? So we have ax squared plus b with a little invisible 1 plus c equals 0. We got him, we got him. We got to put him in, and we got to put him in. Oh, no, we don't got to put him in. He's already here. He showed up to the game. What does this look like? It's going to be plus 0 minus 25 equals 0. Let's put our x's in there. Okay, so we got to figure out what numbers, 2 numbers give me a 0 if I were to add them together, and then what 2 numbers give me a 25 it's a negative 25 if I were to multiply them. Let's see. Well, we know that 5 times 5 is 25. And if we do 5 minus 5, that's 0. So maybe we can use that. We have a positive 5 and we got a negative 5. All right, so maybe we can use that. All right, so let's do this 5, and then we got positive 5. Okay, I got the cosmetics done. I got the factoring done. Next step is taking our factors and making it equal 0. What does that give me? Gives me positive 5. Gives me negative 5. Sweet. Okay, so I got those 2 down. What do I do now? I could box these. I could just put boxes around them and just move on to the next question. If I feel pretty good, maybe I'm kind of like crunched for time. I don't want to do the whole, like, test it again. Just box them and move on. No big deal, right? But we're going to go ahead and test it. So I'm going to do a positive 5 and a negative 5. This is going to be 25 equals 0. And then I'm going to do the same thing again. Let's see, I have 5, and then I got a negative 5. So maybe from the jump you could see, maybe you could predict what our answer is. Maybe not, maybe there's a lot going on. So what is 5 squared? It gives me 25 minus 25 equals 0. 25 minus 25 is 0. Bam, there you go. So we know that the positive 5 is correct. We're good on that. We can definitely submit that as an answer. Let's check the other one. Well, when you have a negative against the nth degree, with 2 specifically, it's going to be a positive number. So we're absolutely 100% getting a positive number. 5 squared is 25. Bring down what's left is 25 equals 0. Well, 25 minus 25 is 0. If I bring down everything else, it's 0. So it looks like that's right as well. Hooray, we got that right. Is there more? Yeah, there's a couple of more. Okay, this is already set up how we need it. Everything's set up perfectly. I got A, I got B, I got C, I got my 0. So sweet, the cosmetics are done. We could just factor. Well, we have something up here, this 3 up here. This is called a leading coefficient. I feel like something goes in the middle here with the spelling, coefficient, well, whatever. Leading coefficient. A coefficient is a number in front of an alphabet. If it's at the super front, like the very front, like the engine of a train, of a math question, it's called a leading coefficient. So that 3 is a leading coefficient. That 4 is not. It's just a basic coefficient. That number 1 is a constant. And that 0 over there, that's technically a constant too. So we have 4 terms, right? This is a term, 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 term. Those are all terms, but we have one single leading coefficient, and that's the number 3. So we have to figure out where that goes. So we're going to have to do 3 in the front here. I can't evenly divide it. Had it been like a 4, then I could maybe do like 2t. You know what I mean? Something like that. But that's not what I got, so certainly we can't use that as an option. We just have to throw it in there willy-nilly. It's going to be a little bit wonky, but we'll get through it. So now it gets a little bit tough because I have to figure out what magical numbers give me a 4 if I were to add, and also gives me a 1 if I were to multiply. But the thing is, I have to be mindful of that 3. So what can I put in there? What would work? Because I can't just pick any number, right? I have to make sure that we're mindful of that 3. Well, if I did 3t times, plus 1, it does give me a 4. And if I did if I did 1 times 1, that gives me a 1, right? That's our little guy that's just standing out. So what do we have? We have 1 and 1. That's a little bit tough, right? Because I don't know if I described it appropriately. It's going to take a minute. You can also use like the FOIL method where you do first, inner, outer, less, and you kind of guess and see what's up, right? So let's try to test it real quick. So first, the inner one is plus 1t. Outer is plus 3t, because we're doing 3t times 1. And then last is just 1. Let me see, my pen keeps freezing. Okay. These are the same terms, so I have 3t squared plus 4t plus 1. That matches up here. So my factoring setup is good so far, presumably, right? Now I'm going to take it and I'm going to add it, equal it to 0. 0. Now I have to, this is why this is a good question. Now I have to isolate t. Now I got to isolate it entirely. How do I do that? Well, I'm going to get 3t equals negative 1. It equals negative 1. But there's that 3 there. I got to get rid of that too. 3 equals negative 1 to the third. And then this gives me t equals negative 1. Right? Those are my 2 that I have. And I think what I'm going to do is, I think I'm going to erase. My goal is to erase this so we can have some room. Because, so the reason I need more room is because I'm observing a fraction. So what that means is we're going to have to do a little bit more math to kind of put together our answer. So let's, so let's do, oh man, I already messed up. Okay. Okay, so I have negative 1 over 3 squared plus 4 times negative 1 over 3 plus 1 equals 0. Okay, so what do? I have to do this multiplication first. So negative, let's do it off on the side here. Let's do our little bookkeeping here. Negative 1 over 3 times negative 1 over 3. What does that give us? Well, we're multiplying. Remember that. We're not adding and we're not subtracting. I have a video on my channel that shows you how to add and subtract and multiply and divide fractions. So we're multiplying here. So we're going to get a positive answer here. We're going to take the bottom numbers. That's called the denominator. We're going to do 3 times 3, which is 9. And we're going to multiply the top numbers, which is called the numerator. And we're going to get a 1. So we have 3 positive 1 over 9 plus 4 negative 1 over 3 plus 1 equals 0, right? So now we're going to multiply 1 over 9 times 3. What does that give us? It gives us 3 times 1 over 9. And anytime you have a whole number against a fraction, we're going to put an invisible 1 underneath the whole number. And we're multiplying, so we just go across, right? 1 times 9 is 9. 1 times 3 is 3. We're not going to reduce. Maybe you can see that we can reduce this. We're not going to do that yet. When you have like a bunch of math ahead of you in the same equation, try your best not to reduce because it complicates the matter. Right? And now we're going to multiply negative 1/3 times 4. What does that give us? It gives us 4 times negative 1/3. And anytime you have a whole number against a fraction, you're going to put an invisible 1 underneath the whole number. And we're just going to multiply across. Negative 1 times 4 gives us a negative 4. And we're going to do 1 times 3 gives us 3. Right, so I have plus negative 4/3 plus 1 equals 0. So here's the thing. I have to make this and this get a 9 in the bottom. So I'm going to multiply this by 3. And whatever I do to the bottom, I got to do to the top. What does that give me? 3/9. That's a plus 12/9. And then we have to do 9/9 for the 1. Where did I get that? What I did is 1/1 times 9/9 equals 0. Now all the bottom numbers are the same, right? So let's do these two. So 9, oh, this is negative. I forgot the negative up here, right? Because this is a negative. Ugh, oh my goodness, this is so messy. I hope you can follow along. Okay, so negative 12 plus 9, right? That gives us a 6. So we have 3 minus 9 minus 3 minus 9 equals 0. 3 minus 9 minus 3 minus 9 is 0 over 0, or equals 0. That's correct. Therefore, this is right. This is the right fraction, right? So let's try the second one now, which is less tedious, less anxiety inducing. It's more straightforward, right? So what did we have? We have 3, what is it, negative 1 squared plus 4, negative 1 plus 1 equals 0. Okay, we're going to do this first. So it gives me 3 times 1. Oh, that's not a plus. And that's going to give me negative 4 plus 1 equals 0. That's going to be 3 minus 4 plus 1 equals 0. And then let's see, we're going to put these two together. 3 minus 4, we know it's going to be negative because that 4 is bigger. 1 plus 1 equals 0. Negative 1 plus 1 is, 0 equals 0. So that's correct as well. Therefore, this is also correct. These are my two final answers. I feel like I really went through that very quickly, so sorry. Okay, we have 2 more to go, if anyone's still watching this. So, okay, so we have what we know as a leading coefficient. So, well, I was going to factor, but we have to remember we have to do the cosmetics and the placeholder. So we got A, we got B, we just need a C, little alphabet C. All I did is just stretch out the formula and I just threw that in there. Right? So what do we have? I have to figure out what I can put, that's an invisible one. I have to figure out what's going to go in there. We know that's going to be 2B right here. This is going to be a standard B. Well, I do know that negative 1 and 0 are useful. We can do that, right? Because I have 0 and then I have, what is that? A 1, a negative 1. So we do have a 2 and then we have a negative 1. So that's how I kind of came up with that. So we're going to go ahead and equal everything to 0. And then we're going to isolate B by itself. That's 1. But we have to make sure that we get that 2 alone too, because we have to make sure B is completely and totally by itself. Right? And then B equals 0. Great. Now we're going to check our work. We could just box this up and say, hey, we're good to go. But we're going to go ahead and check our work. 2, 0. Okay, cool. So we're going to put half in here. We're going to put half in here, and then this one gets 0 and 0. Let's go ahead and do the non-fraction one first. So we end up with 0 minus 0 equals 0, 0 equals 0. That's cool. So b is in fact 0. Let's do the fraction one next. So we're going to do, let's do it here. Half times half. We're multiplying, right? So it's going to be a 4 and a 1. So we're going to do 2, 1 over 4 minus half equals 0. Let's target the first term. So I have 2 times, should I move that somewhere else? I have 2 times 1 over 4. Anytime you have a whole number against a fraction, you're going to take that whole number and put an invisible 1 underneath it. What is 2 times 1? It gives me 2. What is 1 times 4? It gives me 4. Don't reduce because it's going to complicate matters, right? So this becomes 2 over 4 minus half equals 0. Well, I have to make sure that both of these have the exact same bottom number. It's called a denominator. What do? Well, I could put a 2 into this. And what does that give me? I'm going to bring down this 2 over 4. And then I'm going to multiply these. It gives me negative 2. And then we'll multiply these, and it gives me a 4 equals 0. Well, 2 over 4 minus 2 over 4 is 0 equals 0. That's correct. Therefore, this is also right. These are both correct. Hooray! We're doing splendid. Let's try another one. Let's do this last one. And I think we're going to stop after this because I have arthritis in my right hand and it's kind of acting up a little bit today. Let's see. So we're going to go ahead and so we have this problem, right? And here's the formula we're using. Plus c equals 0. So we have to make it look like that, right? This is the cosmetics. We got to make it look like that. Now here's the thing. You don't have to. That's why I keep calling it cosmetics. If you don't set it up in this way, it gets tricky when you start factoring. An alternative is that you can just use the quadratic formula that we mentioned earlier, right? And I do have a video on my channel that shows you how to do it really quick, like how to memorize it really quickly. So what we have to do is we have to find all the like terms and put them together. So let's go ahead and do that. So I'm going to do negative right here, and I'm going to keep it right here because they're like terms. How do I know they're like terms? They both have n squared, right? And that's a. They're both the letter A essentially. Here's A, here's B. This is a C, and then this is A again. So we combine those. This gives me a 0. This is going to be a positive because 3 is bigger, and it's going to be basically 1n squared. Right? Everything else, there's no repeats. There's no repeating terms. Therefore, I'm just going to leave everything else as is. So what is my new question it's asking? It's going to look like this. I brought that down. Plus 1. Because I have to move this over to the other side equals 0. Right? So that's what I'm looking at now. I'm going to factor. What is it going to be? Well, we do know that n's going to go here. And negative 1 minus 1 gives me negative 2, and a negative 1 times negative 1, well, that gives me a positive 1. So let's go ahead and do that. Now I'm going to take my two factors inside the parentheses, and I'm going to set them equal to 0. And then I'm going to isolate my variable. My variable is any alphabet that comes with it. It being the question, so that any alphabet that comes with my question. For us, it's the letter N, so I'm isolating the variable N. So it gives me a positive 1. Great. So they're both the exact same answer, so we don't have to test it twice. We just got to test it once. So let's go ahead and do that. I have 3, my placeholder. Then I have 2, my placeholder equals negative 1 plus 2, and my placeholder. I'm going to put a little 1 in there. I'm just going to shimmy that in. And let's go ahead and try this. So I'm going to go ahead and insert this in here. And let's do this one too. So it gives me 3 times 1 minus 2 equals negative 1 plus 2. Then I have 3 minus 2 because I put these together. equals -1 plus 2. So what is my final answer? Well, 3 minus 3 minus 2 is 1. And then -1 plus 2 is going to give me a positive number because that 2 is bigger. -1 plus 2 is 1. It's a positive 1. It looks like those match up. These are the same. Therefore, these are my final answers. They're the exact same thing, so you only have to submit one of them, right? So this is the exact same thing. Cool, sweet. So that's all the ones that we have. I hope this helped. You know, the video is kind of long-winded. My videos, I feel like they're getting longer. I don't know. I don't really know who my audience is. So I hope this video helped. I do have stickers. I'm putting some new stickers up, so hopefully people like them. I don't know. Okay, thank you everybody. Bye.